All right, hello everybody. Welcome back. This segment is not actually in your notes. These are just a few acceleration examples that I'd like to go through, just kind of for your own benefit. You don't have to do them, but it may help you with your homework. So I'm starting out on this page right here because this is these are our equations of motion. Now you may have slightly different varieties right here. For example, you've got x right here and here. X equals x initial or x original. You can change that to be delta x equals all the rest of the stuff over here, right? And this is delta x equals all the rest of the stuff over here. Because if we subtract over that to this side and that over to this side, we get x final minus x initial, and that means delta x. So just some little variations that you can use. These are going to be our 5 main equations of motion. So we're going to do 2 problems together in this segment right here, and we're going to do 1 or 2 others in separate videos. All right, so let's go ahead and just get started. Okay, problem number 1, example 2.4a. A world-class sprinter can burst out of the blocks to essentially top speed of about 11.5 meters per second in the first 15 meters of the race. Okay, what is the runner's acceleration, and how long does it take her to reach that speed? Okay, so let's go ahead and do a little drawing right here. There's our runner in the starting blocks, and here's the top speed right there. And this is 15 meters, 15.0 meters from there to there. And so she's moving here, and here she is not. So let's start writing down some of our knowns. All right, so top speed of 11.5 meters per second. That's our final velocity, right? V final. V initial is going to be right there. All right, and so let's start writing these things down as sort of like a menu. V final equals 15. Oh, nope, messed it up already. 11.5 meters per second. Okay, in the first 15 meters of the race, so that is our displacement. She displaces 15.0 meters. There's a point in there, 0.0 meters. And we want to find the acceleration. All right, the acceleration we don't know. We also want to find her time as well. But you know what? I'll write time in different color because that'll be a different part of the problem. So, did we write down all of our knowns? It appears that we have, but let's ask ourselves, can we infer anything else? Wait a minute, what is the initial velocity right here? She starts from what kind of speed? From no speed, right? From rest. So we do know the initial velocity too. So sometimes you have to read into the problem to be able to solve it. So the initial velocity is 0 meters per second. That's going to be helpful because generally speaking, if we have 3 knowns, 1, 2, 3, we can solve for any other unknown. So what equation do we use? What kinematics equation do we have that deals with final velocity, displacement, acceleration, and initial velocity? Well, how about this one right here? That is really V final. That's really V initial. VO, VI, it's the same thing. Acceleration and displacement. 2 is just a coefficient, but that's okay, so we can use that. So we can say, here's our general equation. V final squared equals V initial squared plus 2 times our acceleration times our displacement, right? Let's solve for acceleration. So what I'm going to do is I'm going to add over my V initial squared, and then I'm going to divide by 2 and divide by displacement. So it's going to look like this. V final squared minus V initial squared. I do that first, and then divide all that by 2 delta x. Okay? So her final velocity is 11.5 meters per second. Oops, so minus what? Minus her initial velocity. Oh, you know what I didn't do? I didn't square that, right? You need to square it. 0 squared is, of course, 0. And then in our denominator, we have 2 times our displacement, which is 15.0 meters. Okay? That will solve for our what? For our acceleration, which is what the first part of the problem asks for. All right? I'm going to let you do that. I know you can use your calculators pretty well, so we'll save that. But I'll do part B, and then we'll move on to a different problem. Okay, part B asks, how long does it take her to reach that speed? So part B is time. That's what we want to know. Okay. Now, there's a couple different equations we could use. All right, we've got final velocity, we've got displacement and initial velocity right here. Do we have one that can solve for time? Yeah, I think so. Oh, sorry, and no, I circled the wrong one. This one right here. Because this really becomes displacement, initial velocity, final velocity, and time. Now, the other thing you can do is this. If you solve for acceleration in the first part of the problem, and you're pretty sure you got it right, you can use this problem now because now you have acceleration. The only thing is you want to make absolutely sure your problem was right, otherwise you'd be plugging in a wrong value. But let's just be safe and stick with the one that deals with all the knowns that we have. So we can say that delta x is going to be 1/2 times v initial plus v final times t. All right. This part right here really just gives us the average velocity, right? So 1/2 initial plus final. To solve for t, we're going to divide this whole thing down on that side right here. Except actually, if you've got a 2 in the denominator, it winds up being in the numerator, right? So t is going to be equal to 2 delta x over v initial plus v final. All right. Plug in your knowns. 2 times 15 meters divided by v initial 0 plus 11.5 meters per second. That'll give you your time, which I'll let you solve for. Okay? In fact, I'm going to stop right there, and I'm going to do the next problem in a separate video. Thanks for following along. I'll see you on the next one.